every subject basically to execute the project comprehensively. It is important. So whatever equipment or whatever tools are there, you have to start with those tools, and the facilities will follow once you do it. Once you do good research, you write projects, you get money, you can purchase better equipment, and once you are recognized worldwide, people come to know that these papers have been published by these scientists. Then once you talk to them, you write to them, you come in contact with those persons, they start respecting you, they start helping you, they start collaborating you, and that is the only way you can grow. Calculation of LD50 for new drug molecule in mice. It is also known as acute toxicity. Toxicity is acute, subacute, and chronic. Now, acute toxicity means what is happening to the animal or to the living being within 24 hours. What is happening to the body within 3 months is subacute toxicity, and what is happening to the body 3 years is chronic toxicity. And for acute toxicity, because we have chosen the topic LD50, that is 24 hours toxicity, two issues are very important. One is pilot studies and another is regular experiments. Because unless until you conduct pilot studies, you will waste a lot of resources. This is very important to understand why do we go after the toxicity studies of any new molecule. I must have spoken to some of you at one point or the other that there was a time when thalidomide was practiced by very many clinicians worldwide, and it was in 60s. My birth year is 62. I escaped the toxicity of thalidomide because my mother did not consume it. Thalidomide was used by pregnant ladies for inducing sleep. During pregnancy, sleep is disturbed. And the children born to those ladies who consumed thalidomide were limbless. If you look into pharmacology books, you would find that the children were born who were having very short limbs, hands and legs. But this did not happen in the United States because that time the Drugs Controller General, that gentle lady, did not permit thalidomide tablet to be used by any of the patients, antenatal patients in the country, which she was heading as Drugs Controller General, because no toxicity data of thalidomide were available. So it was not permitted to be marketed in the United States. And there's nobody who suffers from this problem, but they say so many persons in India and other Asian countries. So it is very important to look into the toxicity of new molecules before they are approved for making formulations and marketing. And pilot studies are conducted to prevent the resources. Generally, the acute toxicity is conducted on mice because you cannot choose the bigger animals. You cannot choose lions or tigers for this. This is always said that a tiger would experiment on you if you try to do that experiment there. So pilot studies are conducted first, and then regular experiments are conducted for finding out the acute toxicity or the LD50. Viren, ये slide how would it move? ये नीचे तो चल नहीं रही. ये चल गई ठीक. This is how. All right. Acute toxicity, graphical method is there because we are just coming to the corner, because most of us know what is this. Then Spearman-Carber's method and Miller and Tainter method. There are 3 methods. So I'll try to emphasize on the data comprehensively. The Miller and Tainter method is depending on the converting the bigger data into the smaller data probit. For example, the lethality is from 0% to 100%. So data is bigger, 10%, 20%, 30%, 40%. So it is converted into probit. That you convert it into 5, and that would indicate 50% to mortality. And the log dose is involved there. The graph is plotted between log dose and the probit, because there may be 1000 micrograms as the modulus, or 2000, 4000 micrograms. And that may lead to very cumbersome situation when you plot 2000, 3000, 4000 on a graph. So what do? They take the log dose. So 1000 means it is 3. So that way, the bigger figures in case of Miller and Tinter method, they are reduced to the shorter, and standard array is calculated. Now, any method which is used to find out the LD50 would be a comparative study. And representation in graphs has been the method by the scientists to do many calculations. That you can choose certain drugs and their doses, feed the animals or the living systems, and then you can observe what happened during last 24 hours, how many animals got killed by the doses you gave to them. That means that whatever dosing has been done in the mice, you have to calculate that there are certain groups, and those groups, they have been given the dose of a particular new molecule, or say any molecule, and then counting of the animals who died. And then you can plot the curve between x-axis and y-axis. On x-axis, you can write the dose, and on y-axis, you can write the mortality. And that way, you can find out from that curve that when it is 50% mortality, then what is the dose? That is LD50. This means the dose that induces the fatality into 50% of the total number of animals is the LD50. Now, when you make a graph, you have got X points and Y points. You do not have a state curve. It is for show, especially when this is biological data. So people are after regretting the curve. Regression is plotted. That all the points, they are brought to the same line, regression curve. And when it was very difficult to plot regression curve, or it was tedious, or it was a lengthy process of plotting a regression curve, many people, they developed the software to feed the points xy, x1, y1, x2, y2, x3, y3, x10, y10, x10, yn. Standard curve will be plotted automatically within no time. And when I visited the United States way back in 1994, that time I used to plot the curve here in my laboratory. And my supervisor, Professor S.N. Sharma and Professor A.K. Madan, they used to be very happy that I have plotted a curve, seamless curve. No point going this side and that side. And I remember those days, Asghar Ali, my PhD mate, and Harvinder Popli, my PhD mate, they used not to do any calculation. They used to throw the data onto me. They must have forgotten, but I remember. Now, when you plot a regression curve, then you think that the data has been dealt in such a way that it is in proportion. If the X is bigger, Y would be bigger. X is smaller, the Y would be smaller. So you can interpolate and extrapolate the curve to find out the LD50. Spearman-Carber's method is based on the statistical calculation. The median dose is taken So there are certain calculations. So I would like to explain the methods which will let you know the LD50 of a particular molecule. So molecule is selected. I'll tell you how to design the experiment. Molecule is selected and then the formulation is made. The best method of making a formulation is the most concentrated flowable solution. So what can you do? You can take the molecule. If it is water soluble molecule, you can dissolve in water and make a solution that is most concentrated but flowable through syringe. If it is not water soluble molecule, you have to induce the changes or you have to use the co-solvent. DMF would be the best one, is acceptable, and make a solution so that it can be injected. So mice are selected in various groups, or they are not selected, they are taken, they are grouped. When you are doing pilot studies, so you take 3 mice in each group. So you take 5 cages, 3 mice in each cage, and then you would identify them. Because those who have studied pharmacology meticulously, they know that picric acid can be used to mark the animals. A drop is put on the head, a drop is put on the back, a drop is put on the tail. So this is how you can identify that these are the animals, because 3 animals in cage, otherwise you will not be able to make out the one which has been given the dose. So you might give accidentally dose to one animal 3 times and there would be one animal where the dose has not been given. So marking is very, very important. So when you are conducting pilot studies, you are taking only 3 animals in a cage. 5 cages you are selecting, cage number 1, 2, 3 groups. 5 groups are there, 3 animals in one group. So they are marked head, tail, and back. And then you take the weight of the mice, all. Weights have been taken, you write on the piece of paper or you say in your notebook that cage number 1, rat number tail, T, rat number back, B, rat number head, where the identification mark has been there with the help of solution of picric acid, and then you have the weight of all the 3, and then depending on that you calculate the amount or the volume of the formulation, that solution is to be injected. You have to decide the route also, whether it is subcutaneous route or it is oral route, whatever route is there. So generally subcutaneous route is decided right in the beginning so that you have got some idea preliminary. So thigh is exposed, you can hold the mouse. Most of us know how to hold, but it is very easy. You can look into any video. It is very easy to hold a mouse because it is not very powerful. So you inject the amount of the formulation, that is the volume of the solution which you have calculated on the piece of paper or in the notebook. So it would be injected to all the 3. So this would be done in all 5 cases. Cage 1, cage 2, cage 3, cage 4, cage 5. And then the dose would be different. In cage 1, it would be 1 milligram per kg or 1 gram per kg. In second, it would be 2 milligram per kg or 2 gram per kg. In third, it would be 3, 4, 5. It is not very particular that you select the doses 1 to 5. You can select doses 2, 7, 11, 12. Any doses you can select. But there is one principle that in cage 1, the dose should be such that none of the animals dies. It is important. In cage 1, animal, any animal should not die. All the 3 animals, they should survive. And in the last cage, all the animals should die, because that is the minimum and maximum range. But you do not know. That's why we are conducting pilot studies. Now, should it happen like this, that in cage number 1, all 3 survive, and cage number 2, all 3 survive, then in cage number 1, all 3 survive, cage number 2, all 3 survive, cage number 3, 1 dies, cage number 4, all 3 dies, and in cage number 5, all 3 die. It is hypothetical. So this means first reading is waste. Your minimum reading is the second one. In cage number 4, all animals died, and in cage number 5, all animals died. So cage number 5 is waste. Your extreme limit is 4. So you have to decide that which is the maximum dose that is tolerated by 100% animals. That is the idea of pilot studies. That maximum dose that is tolerated by 100% animals, and minimum dose that is not tolerated by any of the animals. Minimum dose that is not tolerated by any of the animals. So in pilot studies, we will choose a dose, minimum dose, where all the animals will survive, and we'll choose a dose where no animal will survive. So this way we'll use less number of animals, and we'll come to know that this is the minimum dose, that is the maximum dose. Now, then we will plot the curve after collecting the data. So let us see, I have made a table for you. This is the table. You can look into it, what I have done. It is there in many of the books, but I have collected that data and put in such a way that you understand easily. That we have groups. So group number 1, 2, 3, 4, 5, 6, 7, 10 groups. I took help of Mr. Virinder. He is a participant also, because I calculated this. It's very simple. You can understand. So all animals, they are having their dedicated cage. 10 animals in one. Now we have increased the animals. There we took only 3. Those were pilot studies. Now this is regular experiment. So 1 to 10 cages and 10 animals each. Now you have to identify all 10 animals. So how would you do? One would be identified by marking at head, at back, at tail, then tail, back, head, back, back, tail, 2 dots at back, 2 dots at tail, 2 dots at head, like this. You have to mark in such a way that those can be noted on the piece of paper or in the notebook. So cage number 1 in the notebook, then animal number head, then head and tail and all that. So you have all 10 animals data, their weights, and depending on the weight, you will calculate the dose of the same solution which you used for the pilot studies. And that way, for simplicity, I told you that you can decide any minimum dose, any maximum dose, whether it is regular or it is irregular. But here, for the sake of understanding, I have selected 1 and 10. That minimum dose is 1 milligram per kg and maximum dose is 10 milligram per kg. And in 10, we found that 10 milligram per kg kills all the animals and 1 milligram per kg does not kill any animal. So minimum dose is 1 milligram per kg, maximum is 10 milligram per kg. And you know, this is X. Try to understand. We are dealing the data statistically. 1, 2, 3, 4, 5, it's 55. Now, if I have some time before 12:30, I'll explain to you one more experiment. If I don't have time, then we'll take it some other time, because the organizers have asked me to finish by 12:30. Dose difference means this minus previous. Previous is nothing, so it is in first case it is nil, and in second case it is 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So 10 minus 9 is 1. So next dose minus previous dose is the dose difference. It is A. Dose is X. The dose difference is A. Then because this table belongs to both the methods, graphical method as well as the Carber's method. And I told you that Miller's method is the one which is reducing the number. And it is based on the graphical method and calculation of the standard error. It is more or less same. Then mortality, that in group 1, when you gave 1 milligram per kg, none of the animals should die. Even when one animal dies, this means experiment is wrong. The regular experiment cannot be conducted. It is a must that in first group, animals should survive, all animals. And in 10th group, all 10 animals, they should die. So this is happening. That in first group, mortality Y, no animal is dying, and in 10th group, all 10 animals are dying, and in between, something else is happening. 2 animals are dying, 4 are dying, 6 are dying, 7 are dying, 8 are dying, 9 are dying, 9 are dying. It is not a regular increase. You should make it out. It should not regular. It is not regular. It can be any. It could be like this, that in 7th group, it could be 5. And in 6th group, it could be 8. This could be the situation, which is not there in graphical method, you know. In graphical method, the X is more, the Y has to be more. If it is less, then graph would go back. But in Carber's method, it can happen because biologically some animals may respond otherwise. So the animals which are there in the higher group, they may resist because biological response is something what is not known as physical data. It is a biological data. Then mean mortality. Mean mortality means in the first group it is nil. In the second group it is how 2 plus 0 divided by 2 is the mean 1. Then 2 plus 4 divided by 2, 6 divided by 2, 3. Then 4 plus 6 divided by 2, 4 plus 6, 10, 10 divided by 2, 5. So this means previous reading of mortality, then current reading of mortality plus and divided by 2 is the mean mortality. It is B. Mind it. Dose difference is A and mean mortality is B. So this is how you are calculating. And in the 10th group, the mortality of 10th group and mortality of 9th group, 10 plus 9 is, but it is wrongly indicated here. It is, bear with me, because 9 plus 9 is 18. That's why 18 divided by 2 is 9. But 10 divided by 10 plus 9 is 19. So it should be 9.5 here. It is 9.0, it should be 9.5, but bear with me. This is for the sake of calculation. Now, what we have to do, we have to have the product of A and B, dose difference and mean mortality. A into B. This cannot be corrected because this is a PowerPoint presentation, so I cannot correct it now. A into B. Product is A into B. You just see. 1 1 1 is 1, then 3 1 3, 5 1s is this, because it is always 1, so it is reproduced. Whatever is written here is written here. So let us see 5 5 5. So this is the total. Product A and B total 56, though it is wrong, but it is the total 56.5. Then X square. This is for something else, but understand here, X is dose 1 2 3 4 5. 1 4 9 16 25 36 49 64 81 100. 10 into 10 is 100. 9 into 9 is this square, X square. It is 385. And then XY. Y is mortality and X is the dose. So multiplied by this thing, and these are the readings, and the total is 426. So this is data for Spearman-Carber's method and for graphical method also. Now let us go ahead. What we are going to do? How do we calculate? These are the modulus of various groups. This LD50 is the Spearman-Carver's method. LD50 is lethal dose in 50% animals is, or toxicity, what we call the acute toxicity, that animals, they die after dosing within 24 hours. minus sigma AB divided by N. Means it is minimum dose. M is minimum dose for maximum mortality. Minimum dose for maximum mortality. So minimum dose for maximum mortality, it was 10 milligram per kg. It was the last group. Minus sigma A into B. A is the dose difference and B is the mortality. There we had a column where we had sigma A into B. So it was total was 56.5, though it is wrong. It is the reading. Whatever reading comes, you have to write, and divided by N. N is number of animals. 10 animals were there in each group. So 10 minus 5.65, the LD50 is 4.35 milligram per kg. That is the statistical method which is used, or the Carver's method. Most of the scientists, they are using for calculating the acute toxicity or the LD50 of any molecule or any new molecule before the molecule can be dealt for preparation of the formulation and use by the human beings. LD50 mean lethal dose, minimum dose for maximum mortality. Maximum mortality means 100% mortality. A is difference and B is mean mortality. This is the explanation of the equation. Now, there we had one equation before I told you. A is equal to Y minus Bx bar. This is how this Y is equal to graphical method. Y is equal to A plus Bx. This is known to all of us. But let me tell all the young teachers and the students who are doing MPharm or those who are doing PhD. Many times I am putting a simple question because I happen to be part of the examination almost in all cases beforehand. Nowadays, it is a different story. Only external and internal examiners, they are evaluating. Earlier, head used to be part of the examination system. So when I ask a simple question that whether your standard curve should pass through zero or not, most of the students, they would reply, yes, it has to pass through zero. When I ask, show me the standard curve, it is not passing through zero, then they will say, I don't know. Or then somebody would start manipulating the answer because they had said that it would pass through zero. Let me tell you, biological curves, they never pass through zero, standard curves. So this Y is equal to A plus Bx is the equation of straight line, and it is a differential equation. It is not a algebraic equation. There are certain equations which are algebraic equations, and there are certain equations which are differential equations. Now, when we calculate A from this differential equation, it is Y bar minus Bx bar. If it was algebraic equation, then A would be B minus Bx. A would be Y minus Bx. A would be Y minus Bx. But since it is a differential equation, I am not teaching you the differential mathematics. Since it is a differential equation, the A would be calculated as Y bar minus Bx bar. And B would be calculated sigma xy minus x bar sigma y divided by sigma x square minus x bar sigma x. When I used to do my research, I used to forget this equation. I have already told you my two PhD mates, they used to throw the data onto me to make the standard curve. And I used to calculate, and I used to forget this particular equation. B is equal to what? If you open up Remington Pharmaceutical Sciences, you will find a modified equation, which is as good as this one. So I used to remember like this: B is equal to sigma xy. Then x is first, so x is bar. and y is second, it is sigma y. Then in bottom, numerator, then denominator, sigma x square is x into x. So first x is x bar and second x is sigma x. So this is xy minus x bar sigma y, then x into x means x square minus x bar sigma x. So this is how we will calculate B. Now, depending on these equations, I had an idea that I should keep these two additional points, which are not there in the books. When you look into the Carver's method to calculate LD50, most of the tables or any of the tables, they are not giving these x square and xy. But I included this data. Why? Because these equations have to be satisfied. So how do we satisfy these equations? Well, this is the method, Carver's method, and then this is B. B is, I have picked up from there only. B is equal to sigma xy minus x bar sigma y divided by sigma x square minus x bar sigma x. And these parameters, they can be picked up from there, because in table we have taken sigma xy 426, sigma y 62, y bar 62 divided by 10, because they are 10 total readings. So this is y bar, then sigma x 55, x bar 55 divided by 10 is 5.5, sigma x square, we squared x there, it is 38.5. So this is all. Now B is equal to, first we have to calculate B. B is equal to this sigma xy, take the modulus from there, then 5.5 into 62 divided by 385 minus 5.5 into 55. B is equal to 85 divided by 82.5 and B is equal to 1.03. So this is B. Now you have got the B with you. Now if you put B here in the equation, then y bar you are having, y the modulus of y bar we are having from the table. B we calculated just before, and x is this 5.5, then this amounts to 0.535. So y is equal to 0.535 plus 1.03x. So this is how we can calculate the y. Now this is the y which is corrected y. This is the dose. X is the dose and y is the mortality. So mortality is not up to the mark, because when you give dose, increase the dose, the death toll is not increasing in the same order. Either it is more or it is less. So when you plot a standard curve, you have to bring to the same line. If it is more, then you have to lessen it. If it is less, then you have to broaden. So this is how you do. How do we do? We go to the next calculation table. Y1 is equal to, y is equal to A plus Bx. X is 1 milligram per kg. Y1 is equal to A plus Bx1. X1 is 1 milligram. And it comes out to 1.03. So the calculation is 1.565. Y2 is A plus Bx. B is same. And X is 2. 3, 4, 5, because up to 10 is the X. We have taken 10 kgs. So these are the calculations that this is corrected Y. Y1 is corrected Y. Y2 is corrected Y. Y3 is corrected Y. Y10 is corrected Y. So these are the corrected Y's mortalities. And the doses are 1, 2, 3, 4, 5, 6, this thing. Now, if you take the x-axis 1, 2, 3, 4, 5, 6, 10, then you have the mortality 1.565, 2.5954, it would give you a state curve, which you can use any software. As I told you, 1994, when I went to US, I found one software, Systat there. Systat, SYS, Systat. And the moment I put the figures there, straight away I got the straight line, and this I learned in the laboratory of Professor Fong in Buffalo, SUNY, State University of New York at Buffalo. So I became very happy. This is the software available. Now, if this software was to be purchased here in India, it would be very costly. the people would not have the computer first, and somebody is having computer, the purchasing software is very costly. So what they did, they gave me a number of CDs. I asked Professor Fang that it would be very difficult for me to purchase. I don't have even computer. So he told, all right, you don't have computer, you ask your institute to provide you computer, but the systat that I am giving you. Later on, I came to know that WHONet, WHO, World Health Organization net, it has got most of the softwares free of cost. You can download. All the scientists, I'm telling you, all the softwares which are needed by the scientists of pharmaceutical world, they can download all softwares available on WHONet, World Health Organization net, and this is also there. Now I am calculating Y0. I am calculating Y0. Y0 means when I put mortality 0. So 0 is here. So 1.03 into 0 is 0. But this constant, y is equal to a plus bx. This constant, a and b, they are constants. B value you can make 0 by putting y0, but a value cannot be put 0. It would be there. So even when the value of y, that means the mortality is 0, the dose would be there. There would be a dose which will not induce any killing, dose which will not induce toxicity. So this point would be there, 0 mortality, but x-axis would have some reading. That's why your standard curve in biological experiments will not pass through 0. Correct? Now we go back. This is the graph which shows where is this is mortality here. It is not in proportion. Just see, it is 25, then 50 should be here, and then 75. But somehow we are able to depict that the dose is here. This is the dose, and this is the mortality. And graph will never pass through 0, because even when y is 0, x has got some value, whether it is negative or positive. Now, this is related to 50% mortality. You can interpolate, and then you can extrapolate, and this dose would be the mean lethal dose in any case, and this is the graphical method. And that is the curve which you could make by putting the data inside the equations. If there were no equations available for you, you would do like this, that this is the x, that is the y, this is the x, that is the y, and the curve would be like hazy curve like this, and you would not be able to make it out. So whenever you want to use graphical method, then you have to plot a regression curve. For plotting regression curve, you need x and y points, and then you need x square and xy readings. So that can be done in the same way. So you can verify your graphical method by calculating the LD50 by Carver's method, and then this data can be utilized for further decisions to be made by the scientist in case of particular molecule, whether the molecule is very toxic or it is less toxic, or it can be dealt further for making a particular formulation. Now, this is the example which has been taken by depicting intraperitoneal IP. No, sorry, subcutaneous dose. That can be oral, that can be local, then that can be otherwise. That you can take any mode of ingestion of formulation of medicine, and then you can collect the data. The data is needed such a way that it is a dose, and it is a dose difference, it is a mortality, it is a mean mortality, it is a product of A and B, x square and xy. So this is how we can calculate the LD50 of any molecule. So that puts a full stop. So I think I do not. So from my side, the things are over. So what to do, Virinder? What to do now? वापस भेजना पड़ेगा.
Thank you very much, sir. Now I would like to request Dr. Ashwini Dhingra, HOD, Guru Gobind Singh College of Pharmacy, to give vote of thanks. Please, sir.
Good afternoon, everyone. On behalf of Guru Gobind Singh College of Pharmacy, with due respect, I would like to extend my heartfelt gratitude to our esteemed speaker, Professor Dr. Gajinder Singh, Dean, Pandit B.D. Sharma, University of Health Sciences, Rohtak, for sparing his valuable time and to be a part of this 6-day online AICT IST sponsored induction program on the topic how to plan experimental methodology in pharmaceutical research. I appreciate your interest in the well-being of the youth, sir. Your expert talk has provided us with an guidelines to proceed more precisely for the calculation of acute toxicity study, including graphical method, Kerber method, for the betterment of this noble cause. We hope that this kindness and your kind cooperation will remain to continue in the future. Your kind presence and expert talk during the program encouraging us a lot, and it will help all the researchers while opting or selecting a particular methodology to pursue their research progress. I again thank you, sir, for your kind talk. Thank you very much, sir.
Sir, as a token of respect, we would like to present a certificate to you, sir. It will be on the screen, sir.
कैसे आएगा, कैसे दिखेगा मुझे उधर दिख, अच्छा आ गया. थैंक यू, आई हैव रिसीव्ड द सर्टिफिकेट.
थैंक यू सर.
थैंक यू. कोई अच्छा, कोई क्वेश्चन तो है तो पूछ लो, किसी से 2 मिनट है तो पूछ लो, कोई क्वेश्चन है कोई? नहीं है.
Thank you so much, sir.
ठीक.
Your PPT is more beneficial to calculate the LD50, sir. Thank you so much, sir, for the PhD scholars as well as MPharm research scholars, sir. Thank you, sir. It's more beneficial to me, sir. Especially.
डॉक्टर अश्विनी, अरे जो दे दो, ये वैसे इसमें कैलकुलेशन थोड़ी गड़बड़ है, वो हम कर देंगे, लेकिन ये वैसे ही समझ आती है, दे दो ताकि लोग थोड़ा ना देख ले रहे. वैसे तो बुक्स में होती है, लेकिन ये अवेलेबल है, 4-5 स्लाइड्स देख लेंगे.
Yes, sir. We are also providing the PPT of the expert talk to all the participants.
तो हम इसको करेक्ट करके भेज देंगे, वो देना फिर है.
ठीक है सर.
एक रीडिंग में गड़बड़ है तो वो कर लेंगे.
ठीक है सर.
चलो ठीक है. थैंक यू वेरी मच.
थैंक यू अगेन सर. थैंक यू.
कैसे करें, खत्म कैसे होगा? यहाँ से लीव कर दे, क्लोज विंडो कर दो. कहाँ से होएगा? फिर यहाँ से लीव. अच्छा, यहाँ से कर दो. लीव दी.